So let's go back to the software now. So now that we talked about the interference, so let's do the simulation. So simulation is pretty much straightforward and automated, but you need to pay attention to the parameters, okay? To the importation of the parameters. You need to make sure you have the right model in place. Maybe before I do that, I need to explain to you here what I did. You see, I modeled every site as, in fact, as 1, 2, 3, 4 sectors. Okay, so these 3 sectors are the actual 1, 2, 3. But the first one, this one, is just the benchmark model. So I have a benchmark model which is Omni, pure Omni. It's a pure Omni, and this is really the most pessimistic case. Although I'm calling this Omni, I'm using directional gain. I'm using the full gain of the smart antenna, 25 dBi. So it is Omni, and it is. If you don't want to use the word Omni, you can say non-discriminating antenna, non-directional antenna. But their antenna actually has a maximum gain, and that makes it directional in every single direction. So this is the worst case you could imagine, because the tilt has nothing, the tilt cannot discriminate the signal. So when the advantage of this is that I can ask the software to do analysis based on this Omni and based on this sectors. Okay, so because when you want to shut down a site, you don't need to shut down the entire site. You shut down the sector which is causing a problem. Okay, we'll talk about this when we do the mitigation measures. So let's continue now. We need to run the analysis. So you go to spectrum and you go to national, regional. So you can see we have a number of coordination automation process, ITU, FCC, NTIA, okay, Europe, and here we have some countries. We have here UK. Now the one I'm interested in is this one. So software is deactivating that feature. That means I missed one step. Yes, I did. So that object here, the radar object, need to be classified, in fact, as a radar. Okay, so you need to classify it as a radar, not a normal site. So here we go. Now it's a radar. So I moved it to radar. Then go back to spectrum, and then national, and then you see it's activated. Okay, so it needs to be radar. So you click on it, and now you put the transmission bandwidth. The transmission bandwidth is 60 meg, if I remember correctly. Sorry, not 60 meg. So this is the transmission bandwidth of the 5G. It's not always 60 meg, like I said before. So you might need to talk to us first to give you the guidelines. It depends how much overlap you have in the 5G band, in the aeronautical in band. As per definition from Ofcom. So here we have the out of band emissions, and this is EIRP, okay, including antenna gain. So the out of band emissions, this is something you need to extract from your equipment. Okay, so it could be neg 90, it could be neg 110, it could be something else. So this is based on equipment. If you want to use the 3GPP guidelines, then I can guarantee you all the sites will fail. So we expect the 5G equipment to exceed the 3GPP requirements. So this is done. 60 meg, you've got here neg 110, and here you need to really, here database station. You need to go back here and select all. Don't forget this step, very important. You need to select all of them. Max distance up to 7 kilometers. So the software will ignore from the station database any. So you could have the national network in that database, and still the software will ignore all the sites outside 7 kilometers radius. Okay. So and the model I already see there's advice here to use 452.16 with 0.1%. So go double check. Yes, it is 0.1%. So it is okay. So I'm going to use this technique. We have so many techniques here to do interference calculation. This technique, interference one at a time. So it's taking one sector at a time. Okay. And I know you want to use the combined effect of multiple sectors, but I'm usually taking care of this using the benchmark model that I talked about. The Omni antenna was 25 dBi. So this is my benchmark, which will be the very, very worst case scenario. Okay, so you could use the combined analysis. Okay, so you could power sum for collocated stations. So you can combine all the sites falling in the same location. You can combine the powers based on antenna discrimination, of course, and then the tool will will just flag the first sector that fails. Okay, as soon as it fails, we will just report the first the first sector to cause a problem. So you could use this technique as well. Now, because I have the benchmark model, I cannot, it's not fair to combine the benchmark model with the individual sectors. So I'm going to use this technique for now. Okay, I prefer this technique because it's giving me control. I can later on calculate if there's combined impact. So the idea is that one can start with a site model only, and then the sites that are problematic, you can upgrade them to sectors and then study the problem. So I'm gonna use this and then hit OK. So do you want to select unwanted station? You can say no, you can say yes. But if you say yes, the software is going to select from the station database the sites that are problematic. Okay. No, I don't need this step for now. I'm just going to say no. And then I'm going to see the report. This is the report. So the report is very useful. I'm going to delete this all. I'm going to go here, data. And then I'm going to go with the filter. And I'm going to sort by distance. So smallest to largest. Here you go. So knock means failed. Okay, failed for some reason. We'll talk about the reason soon. Okay, knock means failed. Okay means okay. So when you look here, this is my convention. So when I see 975, for example, this means this is my benchmark site. When I see 1 to 3, that means individual sectors. So this is my benchmark site model, and this is my individual sectors. So I can see how they fail. So the benchmark is failing, and the individual sectors are also failing. Okay, now I'm going to introduce here another, I can introduce an equation. Okay. All right, here you go. So this is a simple formula. So it says if the margin, we'll talk about each one of these. If the margin is negative, that means you failed the Ofcom requirements. Okay, for either in-band signal, this is a signal, or in-band. This is the margin for out of band, which is the noise. Okay, these two are critical things, critical information to look at in your analysis. So the margin tell you how much you failed or how much you passed. If it's a negative, it means you failed definitely. If it's a positive, it means you passed, and tell you how far you passed. Here is the equation. So the equation says if the margin for out of band emissions for the noise is less than 1, so I have 1 dB margin here, it should be less than 0, then you power off that sector. Otherwise, if the second margin, which the in-band part, it depends how much overlap. Okay, so you can recommend 20 megahertz or 40 megahertz or 50 megahertz reduction to your transmission bandwidth. And this is something case by case. Obviously, I cannot give you a generic figure now for depending on your network, how much overlap you have in the in-band. Then you can propose a suitable shutdown or reduction of transmission bandwidth. Otherwise, it passed. Okay. So let me talk about each one of these first. So here we have the radar, the impacted radar. Here we have impacted radar. The frequency. Here we have the call sign, the sector we are looking at. So this is the site, and these are the sectors. And you can see here we have address, for example. I'm using the address field to say it's a site, it's a sector. Frequency, this is the radiated power. It's also good to talk about this here. This is the threshold. So software is calculating the threshold, protection threshold, and calculating the unwanted signal, 31.8. The protection is 1.9, so you failed miserably, really. So here you are significantly above the threshold. That's why the margin. So the margin is simply this minus this. Okay. So this is the margin. You failed by 29 dB. Very, very bad situation. And here is the threshold for the noise. You can see here threshold for the out of band emissions, and here how much is out of band emissions. So again, the margin is simply